All right, so we have an example problem on the screen. If you like working problems, stop this video and see what you can do with this. But it is complex, and I wanted to talk you through the problem-solving process with this one problem here. There is a lot going on, so let's just kind of examine what we have. We have a mixture of two organic compounds. It's cyclohexane and naphthalene. So I am going to draw, I don't know what kind of mixture it is, so this is just a blob of it. And I know it contains the two substances, C6H12, okay, and that's the cyclohexane, and naphthalene, which is C10H8. What do I know about this pile of these substances? I know that the two things together have a mass equal to 1.32 grams. Okay, so that's the first thing I know as I read that. It says I have a mixture of those two things that weigh 1.32 grams. Okay? They dump this material into some benzene, that's the solvent, and we see what the freezing point does. So we have a freezing point depression occurring there. Normally benzene freezes at 5.5 degrees Celsius, but this mixture freezes at 2.2 degrees Celsius. And we're being asked to calculate the mass percent of the mixture. Now what do they mean by that? Here is our end game. What is the percent of the C6H12 in that pile? What is the percent, and this is a percent by mass, so I'll write by mass above here. It's a mass percent. What is the percent of the naphthalene, C10H8, in that pile? Well, we know that those two percents have got to add up to 100% because that's all that's in the pile. They want to know those two things. So if I'm wanting the mass percent of the cyclohexane, I need to know the grams of C6H12 in this pile. I don't know that, but I need to know the grams of that divided by the grams of the mixture, which I do know that, don't I? It's a 1.32 gram mixture. And then I'm going to squeeze in here times 100, okay? Times 100, take my word for it, that's what that says there, okay? Times 100, that would be the percent by mass, the part over the whole, times 100. Of course, for the naphthalene, it would be the same thing. I could subtract this number from 100 and get this answer, or I could take the grams of naphthalene over the grams of the mixture times 100. So somehow, with this information, I'm going to be able to get the grams of those guys. And it's not very straightforward and intuitive. So let's see what we can do. Let's let X equal the mass of the cyclohexane. Okay? That would be what would sit right here. Okay? Let's let Y equal the mass of the naphthalene. Okay, let's just use those variables here. So what do we know so far? What does X plus Y equal? Well, it's the total mass of the pile, 1.32 grams. So we have two unknowns in this one equation. Well, if you remember back to algebra, if you have two unknowns, how many equations do you need? You need two equations with those two unknowns in order to solve for the variables. So I used the first sentence to come up with this equation. I'm going to use the colligative property of the freezing point depression to come up with the other equation that has those two unknowns in it. So let's see. Let's go to our freezing point depression information here and pull out the freezing point depression equation. Okay? Let's plug in what we know. We know how much the temperature changed by, don't we? It changed from 5.5 degrees down to 2.2 degrees. We know the freezing point depression constant, okay? And that for naphthalene was 5.12. Okay? These are non-electrolytes, so my I is 1. And we can solve for the molality of this solution. So I subtract these two, which is 3.3. I divide by 5.12, and I'm going to get a molality value of, let's see if I can find it. Oh, it is 0.6445. So the molality is 0.6455, and the units, it's molality, or moles of the mixture per kilogram of benzene. Okay, that's what we know. Okay, we know the molality. That doesn't help me yet. I don't have an X and a Y in there. Let's get rid of the benzene and work just in moles of the mixture. How would I do that? Well, let's multiply by how many kilograms of benzene I have. What do I have? 18.9 grams of benzene is 0.0189 kilograms of benzene. The kilograms are going to be canceling, and I'm left with moles of the unknown. 0.0122 moles of the mixture. In other words, the moles of the C6H12 plus the moles of the C10H11 together have to add up to 0.0122. It still isn't quite X and Y, is it? Because X was mass. How do we go from mass to moles? What do? We end up using molar mass. So let's replace this with an X value. The grams of C6H12, let's have this many grams. I don't want grams, I want moles. If I were to use a molar mass of C6H12, which I happen to determine as 84, that would give me moles of the C6H12. Okay? I'm replacing what's sitting here with something that has X in it. Is moles not mass divided by molar mass? Would that not leave me with moles? Yes, it would. All right, so let's do the same thing for the C10H11. Y was my mass of C10H8. This is in grams. I don't want grams of this. I want moles of the C10H8. So I get the molar mass of that compound, which is 128. The moles of X and the moles of Y have to add up to the total moles of both, which I determined had to be this from the colligative property. Now I have a second equation. I'm going to neaten it up a little bit. X divided by 84 plus Y divided by 128 equals 0.0122. Now I have two equations. Here's the one, okay? Where was the other one? It was right here. Two equations with two unknowns, and now I can do the algebra. I think the first thing I'm going to do is take this equation and I'm going to solve for X. So X is equal to 1.32 minus Y. You agree with that? Then I can come down here and replace that 1.32 minus Y where I see X. 1.32 minus Y over 84 plus Y over 128 is equal to 0.0122. Now I have one equation with one unknown in there, and you just have to solve for Y. You could stop and see if you can solve for Y. Once you solve for Y, you could plug it in here and get X. Once you have Y and you have X, then you are going to be able to get the percents. Okay, so I'm going to see if I can solve for Y in this little space over here to the right. Okay, the first thing I'm going to do is get a common denominator between 84 and 128. Okay, so I'm going to I'm going to do this and make myself a little bit more room if I can. I'm going to have 128 times 1.32 minus y, okay? That's going to be, my common denominator, by the way, is going to be 84 times 128, which is 10,752. Okay, that's my common denominator. So I have this 84 times 128, and I have this part times 84, so I have plus 84y, okay? And all of that is going to equal my 0.0122. Now, if I multiply this over and do the distributive property here and combine my y terms, okay, I'm going to, so 128 times 1.32 is 168.96. 128 times a negative y is minus 128y plus 84y. So that's all my numerator. And I'm going to take this 10.752 and multiply it over here. And I have 131.17. I'm going to combine my y terms, okay? There's more negatives here, so I have a negative 44y. That's combining those, and I'm going to get that 168.96 over here. So I'm subtracting 168.96 from both sides, and that is going to give me a negative 37.79. Then I want to divide both sides by a negative 44, and that's going to give me a y equal to 0.8589. I now know y. What was y? Y was the mass of C10H8. So I know that I have 0.8589 grams of C10H8. What was x? 1.32 minus that 0.8589. And that is going to give me the amount of x. Oh, let's see if I can find it somewhere on this piece of paper. There it is, 0.4611. So that is the grams of C6H12. This was the grams of C10H11. So let's just get one of these percents. Let's get the percent of the C6H12. It would be the grams of C6H12, which is 0.4611. So I'm doing this one right here. Divided by the total grams, 1.32 times 100, and that will give me a percent of the C6H12. The percent of the C6H12 is 35%. So what must the other one be? 65%. You could get 65% by subtracting it from 100, because the two have to add up to 100%. Or you could say, well, let's go back and try the other. Let's take the grams of C10H11 and divide it by the total grams, multiply by 100, and you will have that value. So here's a case where two equations, two unknowns, and solving them simultaneously to get your answer would be involved in order to work this problem.